Okay, so what if our entire understanding of physics, everything from the tiniest particle to the biggest galaxy, was missing something huge, something fundamental? Well, today we're going to dive into a theory called Tetryonics, and it basically proposes to rebuild physics from scratch, all starting with one simple, really powerful idea.
And here it is. This is the core premise right here. The whole idea is that the fundamental rules of our universe, well, they aren't just described by math, they're literally shaped by geometry. Now, that is a pretty bold statement, right? So let's unpack what that actually means.
The theory basically reimagines our entire universe. It suggests it's not built from these abstract points and waves we usually talk about, but from a single, perfect shape. We're going to see how Tetryonics proposes that this one fundamental building block can construct, well, everything, from the tiniest particles all the way up to the atoms that make you, me, and everything around us.
All right, let's kick things off with that main idea. Physics is equilateral. You can think of this as the foundation for the entire theory. It's the one single rule that everything else is supposed to come from.
So what this means is, instead of thinking about, abstract forces and these tiny dimensionless points for particles, Tetryonics wants you to actually visualize everything, to see it all as having a distinct equilateral shape. It's a huge shift, really. We're moving away from pure math and into tangible, physical geometry as the real language of the universe.
Okay, so if everything's built from geometry, what's the fundamental brick? What's the building block? Well, let's meet the star of the show.
Say hello to the Tetryon. According to the theory, this little four-sided equilateral pyramid of energy, this is the very first stable unit of mass and matter. It's basically the indivisible atom of geometry, the thing from which literally everything else is built.
Okay, so here we see how that one tetryon becomes the basic Lego brick for, well, everything else. It's defined as a 4-pi mass geometry. And in this system, pi isn't just a number from your math class, it's actually quantifying a fundamental unit of this energy geometry. So think of a single 4-pi tetryon as the foundational packet of stuff. All these other particles you see, they're all just different combinations of this one simple, elegant shape.
All right, so here's where it gets really interesting. How do you take this one simple brick and build all the particles we already know from the standard model? Let's see how it's supposed to work.
So let's take the electron. In standard physics, we think of it as just a point, with no size. But in Tetryonics, no way. An electron has a real, defined structure. It's called a 12-pi quantum machine, which sounds complicated, but it just means it's built from 3 of those 4-pi tetryons all joined together. They form this stable, rotating shape. So it actually has shape and volume. It takes up space.
So what about quarks? Well, you guessed it, they're also built from tetryons. In this case, it's 2 of them stuck together, making an 8-pi octahedral shape. And you know their famous fractional charges? The theory says those aren't just some random arbitrary numbers. Nope. It's a direct result of the geometry. The charge comes from the exposed triangular faces, the fascia, of the shape itself. The shape is the charge.
And this is so cool. This shows us how protons and neutrons are put together. Just look at them. They're basically geometric mirror images of each other. The idea here is that their different properties, like why one is positive and one is neutral, don't come from them being made of different stuff. It's just a different arrangement, a different way of assembling the exact same underlying quark shapes.
So here's the key takeaway. A proton has that up-down, up quark geometry, and that gives it a net positive charge. But the neutron? It just flips that around to a down-up-down arrangement, and boom, net neutral charge. It's the same parts, just put together in a slightly different order. Okay, so we've built particles. Let's climb up to the next level. If we can make protons and neutrons, how do we stick them together to build the nucleus of an atom? And once again, the answer is geometry. That strong force that holds the nucleus together, in this model, it isn't some separate, mysterious force. It's just pure geometric attraction. Think of it like magnets snapping together. The oppositely charged faces of the proton and neutron shapes just naturally lock into place. The process is actually pretty straightforward. First, a proton and a neutron line up. Remember, they have those mirrored charge patterns. Then, their opposite charge faces attract each other and click. They snap together to form a stable nucleus called a deuteron. And now, this deuteron nucleus, it becomes the next major building block in the system. It's like a pre-assembled component.
This little two-brick combo of a proton and a neutron can now be used to build all the heavier elements just by stacking them up in very specific geometric patterns. This model gives you a really visual way to get your head around isotopes. I mean, look at the hydrogen family here. Deuterium and tritium, they're not some totally new thing. They're just plain old hydrogen, but with one or two extra neutrons geometrically tacked onto the nucleus. It really is a purely architectural system. So, let's zoom out. What are the bigger implications of all this? If a model like this actually holds up, it's not just a new theory. It's a completely new blueprint for reality itself.
The periodic table of elements, it stops being just a chart you memorize in chemistry class and becomes a literal architectural blueprint. Each and every element corresponds to a specific, stable geometric shape, built by stacking those proton-neutron blocks into these neat, compact shells.
And this whole framework doesn't just stop at atoms. It claims to organize the entire particle zoo. This chart sorts every known charged particle into these tidy little families based purely on their underlying tetrayonic geometry. So what used to be a really confusing mess of different particles suddenly becomes this organized, logical system, and it all comes from that one single shape. Now, if this geometric blueprint is actually right, then it's not just a new way to describe reality, it's a new way to engineer it. If you can define the precise geometry of matter, well, that could open the door to manipulating it in ways we've only dreamed of. Let's look at one potential application that's proposed.
This is an idea for something called a quantum battery. The thinking goes like this. If you know the exact charge geometry of an atomic nucleus, you could, in theory, design systems to pack energy right into that stable structure and store it there forever. And then you could release that energy whenever you need it. I mean, we're talking about a total shift to true engineering at the atomic scale, and it's all based on this geometric blueprint.
And that really brings us to the final big question. Tetryonics gives us this vision where quanta isn't just a packet of energy, it has a shape. The universe has a shape. And it forces us to ask, what if reality is an architecture? What if it's all built from one single equilateral rule? And we are only just now finally beginning to read the plans?